All right, so for Lab 4, kind of a couple of parts to this. One is to kind of show how you would write your own logic to embed model experiments in a sort of a script using NetLogo coding to do that. Turns out NetLogo does provide, and later in the course we're going to spend some time using a tool that has kind of replaced the need to do what we're going to do in the lab tonight, but it's really useful to know how to do this because the automated routine called behavior space might not be able to do exactly what you want, and it would be useful just to know that there are other ways to skin the cat in terms of getting data captured, loaded out into Excel, and analyzed. And I forgot to mention in the previous slide that in addition we're going to work a little bit with a model and run some experiments with a little simple fire. It's simple looking, but it's a pretty neat little model. And then kind of the challenge part of that is to combine the two parts together and run the fire model in an automated way, but first we'll run it kind of manually to see how you would kind of get that same kind of data, kind of running the experiments one at a time by yourself. So the main thing is to print out multiple variables on the same line. This is sort of some basic primitives. You use the type command. So if you say type something, down in the command center, items will be printed, and they'll be printed across the page basically. And if you want to kind of invoke a line feed, you use the print command. And I've provided a template for this kind of logic, which we're going to build here in the lab. In case you want to refer back to the actual code, it's in the class website. But I'd recommend that you either type this stuff in or kind of build it yourself before you just borrow the code and play with it. It's actually useful to, as I've indicated, especially in these first few labs, to get more of a feeling for the code by typing it in, thinking about it as you go. All right, so what's going on here? First of all, this little bit of code sets up, has time and what simulation number we're going to run multiple simulations, so we need to know what number we're on so we can know when to stop. So we have a utility called to run a simulation set. That's kind of our main go button, if you want to think of it that way. We clear all, we set the sim number to 0, and then we repeat by a variable that's over in the interface called number of sims. We then run the simulation that many number of times. And run sim is right below here. I'll explain that in a second. And then we save the output. There's a command in here which is commented out, save output as, and that's just to give you an idea that we could be saving the output out to a file, and this is just there for reference. To run a simulation, it sets the sim number to the starting number plus 1, which since we started at 0, then we'd start with sim number 1. We reset only the variables. This is a routine that is going to reset the things that we want to reset by run, but not necessarily clear everything, because that would clear the name of the variable called sim number, for example. Then we clear the turtles, clear the patches. So we're mostly clearing it out. And then we run the setup routine, and then we repeat by the length of the simulation go. So if we're going to run it if the simulation length is 1,000 ticks, then it will run go 1,000 times, rather than running it forever, because we have a stopping point. We want to actually pull off what's happened after 1,000 ticks of the clock. And then setup turtles is really simple. We just create 100 turtles. So the model here is actually trivial, but it's just to illustrate the infrastructure for being able to make multiple simulations. The go button just asks the turtles to run the command turtleGo, T-go, set the time to the next time period. So we're incrementing the clock. There also is a command called a tick command, and this is just a slightly more manual way to do it. Tick works fine if you want to just put that in your go procedure. Kind of does the same thing. If the time is a module of the print every, so we don't necessarily want to print out what's happening every tick of the clock. So if we want to print out every 10 or every 100, just sort of see what's happening through the sim, capture what the state of the system as we go, we can use this idea here, and then we print the output. And print output is going to put, well, we'll see that routine in just a second. Another little utility routine is the one that we mentioned above, which was to reset variables. We just, in this case, the variables is time, and so we set it to 0. We might need to set other variables to certain values as well. And this one's very simple. And to print the output, we do some type commands, as we mentioned earlier. We type the sim number, we type a little space, we type the time, we type a space, and then we finally issue a print command, which is the count of the turtles. So we have a very simple little output here. And that a print command is going to invoke a carriage return. So line by line, we'll be able to see the data for that particular print interval on the run of the model. Reset just does a clear all, and the go procedure just says go forward 1, and if random of 100 is less than the probability of death, another thing from the interface, then die. So that over time, those are going to die. So this is a trivial model, but just to test the interface. The interface is fairly simple. You create a few sliders for the number of sims, the sim length, the print every, and the probability of death, and then buttons for running a sim set, and then the reset button. Optionally, you can add some monitors. There's a couple shown here for the sim number and the time, just so you can watch what's going on besides just seeing things happening on the screen. And that template is over on the course content. And when you run the model, it'll show the information that you've displayed out there, and the output data at the print interval will be printed out in the command center. All right, so to actually demonstrate this, I'm not going to go through the process of typing or copying into code, but here's the demo template model, which you could create yourself or grab, and let's just review. We have all the code here. This is the code that we just reviewed. And over on the interface tab, we have the 2 buttons, the 2 monitors, and the 4 variables. If you want to figure out what size they are, you could look and see, just as an example, we could open probability of death, and that obviously goes from 0 to 100. Print every could go from every 100, say 0 to 100. Sim length could be anywhere from 0 to several thousand potentially. Number of sims could be 6, 10, 20, whatever. The reset button points directly at reset, of course. And the run simset points to the run simset command over in the code. And these 2 monitors just report out the sim number and report out the time. So very simple. And when we run it, we hit reset. When we say run simset, we see that the model runs several times, and then just let me go ahead and expand the command center to take a look here. You can see that we ran this model for the first run, and we captured it every 20 at time 20, 40, and 60, the number of that we have, and then if you see run number 2 at time 20, 40, and 60, how many turtles were there, etc. So just a very simple demonstration of a way to control, in this case, a trivial model in order to make multiple simulations, capture the data. And now I can copy and paste. I can just highlight this here and go Control-C and take it over to Excel. We'll demonstrate that a little bit later. All right, for part B of the lab, we're going to go ahead and build the simple forest fire model and then create a user interface for that before we try to link that with the setup. We're just going to try to use this to run some experiments manually, and then we'll try to link the 2 parts of the lab together. So when you set up the interface, it's pretty obvious now, I think you know from the previous labs, where you need to set up variables over on the interface to match up with the code, etc. I will read through the code and just talk about how it works, and that will give you some ideas on what you need in the interface. And then go ahead and run the model a few times to see if it works the way you expect. So you see here, time is the global, patch's own fire, and something called fire time. To set it up, we clear everything. We set up trees, we set up the fire, we set up a border, set the time to 0, and now everything's ready to run. The go procedure tells grow, which we'll look at in a minute, spread, and then ash. Now let's take a look at the setup procedures. To set up the trees, we'll ask the patches, depending on the random number, if it's less than a certain percentage, then set the patch color to green. So just randomly set some fraction of the patches. The higher the density, the more of them will be set to green, and those will be trees. To set up the border, we just look around the outside edge, which is plus to minus 16 all the way around, and we set the edges equal to blue. And we're going to use that to just kind of know when we've reached the end of the spaces. The fire tends to run from left to right. Now for the procedures that actually spread, etc., we diffuse the fire by 0.8, so that means we send most of the fire around to the neighbors and leave some where we are. If we diffused 1.0, then it would all be diffused. There'd be nothing left on the patch we're on. So it's just a built-in command for spreading values across the environment. Then we ask the patches if their patch color is blue or black or brown, set fire to 0. Now, if fire is greater than 0, then set the patch color to red. So we're just trying to color the situation. After we do the spreading, we recheck and recolor it, basically. To grow, we ask the patches, set fire equal to fire times 5, so make fire much bigger. Then, if the color is red, set the fire time equal to fire time plus 1, which means how long did it take this patch to burn, basically. So it's going to keep accumulating that until there's no more fire, and then it'll stop accumulating. We'll just have on that patch how long the fire burned at that patch. And then finally, to ash, we ask patches if the fire time has been more than 2, then it's burnt. So this is a way of keeping track of how long do we let a patch burn. Let it burn, in this case, just for a couple of times, ticks of the clock. We set the color to brown and set the fire variable to 0. It's no longer burning there. And that's it. Pretty simple. All right, to demonstrate the fire model, I did what most of you will probably be doing, which is to cut and paste the code out of the HTML into a new NetLogo screen, and I've done that and pushed the check button. That's all I've done so far, and it says I need percentage. And as we learned, if we go Control-C, it'll capture that label. Go over to the interface. If we want to add, in this case, a slider, you can say add, and put down a slider. Control-V for percentage. Probably should go from 0 to 100. Initial value 50. That makes sense. Okay, so there's the percentage variable. Back to the code. And check again. And we don't get any errors this time. So now all we need to do is create a couple of buttons. So we need to add a button for setup. And then we could have a button for go. Let me just check to see that it was named go. I believe it was. We have to setup and to go, so all we need is a button for go. now we should be able to run the model. Set up. Go. This fire didn't burn very far. Let's set up the percentage a little higher. Set up. And go. Doesn't seem to be burning. That's interesting. Oh, I see what's happening. Every time I push the go button, it burns a little further. So my mistake was I forgot to check in the button forever. So I'm going to redo that. I'm going to re-push setup. Got a high percentage. It ought to burn all the way through. It does. I'm going to lower the percentage way down. Setup. I still have to go on, so I need to turn that off. Setup. And now with these lower percentages, it doesn't tend to burn through because there's a lot of gaps. Even so, it sometimes burns most of the forest, even with this lower percentage. If it were a really low percentage, then it's not going to burn hardly at all. That one doesn't burn. Set up. You can see it doesn't burn very far. I'm just letting it run as soon as I set it up. So I think we can assume that this relatively simple model is working. All right, next we're going to create a plot, add a plot to the showing the number of trees not on fire, the number of trees on fire, and the number that are burnt. The instructions here are fairly clear. We'll click on the plot icon and place it like we would a slider or a button. We'll modify the pen name from the default to trees and make the color of that pen green. And we'll add two more, one called fire and one called burnt, with two different colors. Now we could put logic in here, but instead we're going to update the logic over in the code. We'll have the codes update the values that are going to be plotted by the pens. The modifications to the code are to add a command called doPlot, which is shown below to the end of the go procedure. And then we'll verify that this works. We'll demo this in just a second. So the code for the doPlot is to set the current plot pen to trees, then count the patches with p-color green, etc., etc. It's very straightforward. So you can see how it's linking the code back to the things that we defined on the interface. All right, let's demonstrate adding the plot. I just made my window a little bit wider so that I can grab the world here. Move the world over to the right a little bit, so I've got room for a sort of modest sized plot. Now I want to change this to plot. And then, so the default plot one, we want to change the name of that one to trees. Or the plot can just be tree status. And the pen name here is going to be changed to trees. And the color is going to be green. So we'll just pick a nice green color here. I'm just going to take this one right here. You can't see it, but over on the left I'm pushing the green button and saying, okay, those are off the window. Sorry about that. Now then, we're going to add a pen. And this pen is going to be called Fire. Over. Fire. And its color is going to be red. So push the color choice. Again, this is off screen, but I'm just going over and finding the color red, which is up near the top to the left, and saying OK. And you'll see that that's red. I want to add another pen, and this one is called Burnt. So I'm going to back over those names and call it B-U-R-N-T, and that's going to be a brown color. I'm picking brown, which is about a third of the way down over on the left, and saying OK. You'll see that when you do this for yourself. And then OK, so we've got that tree status ready to plot, and I'm going to just make that a little bit bigger here. I believe if I select it, I can drag it a little larger like this, so it'll be a little more visible. Okay, now we need to go over to the code and add some code. I paused the recording and I just typed in what you see on the screen, to do plot. I typed in the first two lines, and then I copied those two lines twice again and just changed the words trees to fire and color to red and color to brown and to the word burnt. So as long as these match up properly, we should have that. Then the only other thing we need to do is we need to add do plot at the end of the go procedure. So we have dash. Now we want to say do hyphen plot. Check to make sure everything looks all right. It seems to. Go over to the interface, do a setup, and a go. And now it looks like we have a plot, but it's not very interesting. Probably want to slow things way down, and not way down. Maybe change the percentage to a higher percentage so we'll see it burn across more likely. Do a setup, and then a go. And now we can see it plot as we go. And now the model keeps running at the end of the run because we didn't specify an end time on this model. But you can see now that the plot works. Next, we're going to add to the model logic to print out into the command center the time when the fire stops and the number of trees left standing at that point. Then we're going to run some experiments to determine the tree density that results in the fire spreading to most trees and up to the right corner of the screen. You'll want to probably do several runs at each percentage value, at least 6, in order to not just have a single random value, but more of a little bit of a pattern. A simple way to do this would be to add logic at the end of the go procedure that says, if else, count patches with p color red equal to 0, that means we've stopped, everything's done burning, then print output and stop. And then set the time to time plus 1. This will work for making single runs one at a time. We'll have to use something slightly different using the earlier example from the beginning of this lab if we're going to run a set of simulation runs. The code for the print output procedure says, just like we kind of looked at simpler examples, this is pretty simple too. Type the percentage, a little bit of space, type time, a little bit of space, and then print, which means it's going to invoke a line return after this, count patches with p color equal to green. So that's the number of trees that are still left standing and unharmed. The output will print in the command center. Just try several density values. Every time you do it, you'll be adding a line. If the command center, if you get garbage that you didn't want in there, you can just hit clear the command center. But of course, once you've done that, you've lost the data. So do that judiciously. And then you can capture that data with a Control-C down in the command center, and then save it into Notepad and maybe give it a name like Forest Fire Data 1 or something like that. All right, so we're back in the NetLogo. I just pushed the code tab from where we were a second ago. And here, right, I happen to be positioned because we just put in the do plot command. Here's where we would hit carriage return and if else count patches with P color equals red equals 0, parentheses, left brace, print dash output. We'll have to put that in a second. And stop. Otherwise, just set the time to time plus 1. Set time to time plus 1. Okay, we can check the code, make sure there's not any problems there. Nothing named print output has been defined. Yes, I would expect that. Now we go down to the bottom and go ahead. Just say, I'll pause the recording while I type this in. All right, I just typed in this, and what I noticed, at least on my screen, when I hit the tab key, the spaces didn't move over. I couldn't see the tab key. Hopefully that worked, and we'll see if there really is a tab there. That's helpful because you can use tab delimited to detect fields easily when you import data into Excel, which we're hoping to do in a little bit. All right, so let's check the code. If else expected 3 inputs, a true false, a command block, and another command block. So apparently I goofed up. Yes, I had set time is supposed to be in brackets, so I should have put set time like and it's missing the final block even in the code there, so clearly it should be like this. Now let's see if we're okay. Now we're good, I believe. So let's go back to the interface, and now when we say set up and go, at the end of that run, we should see some data show up. And what's happened here, I can see now that I don't see any spaces in there. I'm going to go ahead and add spaces, and hopefully we can detect space delimited when we import the data. So I'm going to pause for a second. Well, no, I'll just go back over. This is easy enough. I'm just going to go back to the Code tab, and back here where at the bottom where I do the plotting, I need to go in and add some spaces here. At least one space, so we can see those fields separated from each other. I'm not sure why the tab character is not working. So I think now if we go back to the interface, and because this is kind of garbage, I'm going to clear it, and I'm going to do another run. And I can speed this up at some point. Right now I'm just letting it run. Now we can see that at the value 64, at time 38, there were 4 trees that didn't burn on this particular run. Now if we want to do 6 cases like this, I'm going to speed it up a little bit. I'm just going to go set up, go. Set up, go. And each time I'm getting another value. Set up, go. Set up, go. And one more time. Set up, go. Now I'm going to change the value. So I'm going to go ahead and pause the recording. I'm just now going to go ahead and change it to different values like 62, 60, 58, 56. I'm going to run 6 runs manually, but that'll take a little while. I'll just pause this recording. There's no point in wasting airtime. All right, so I just ran a bunch of experiments. I'm down to 52, counting down by 2s. And so now if I go to the command center and highlight up to the top, I can go Control-C. Now I've got that data in the buffer, and now I can go ahead and run Notepad. I'm going to pause this and make sure that my capture screen is sitting on Notepad when it comes up. All right, so I've opened up Notepad, which is in Accessories, and I'm just going to go click Control-V, and you'll see my string of data is here. And I'm going to go File, Save As. I'm going to put everything in my Google Drive. Here's the class number. I'm going to go ahead and put this in Slidecasts for week 4. I'm just going to save my data there. I'm going to call it FF. What did I say to call it? FF. Caps FF DATA 1 text. Save. Okay, for the next part of the FIRE model and learning about running experiments, open Excel, go to the Data tab, and then select from text, find the file, and you should be able to preview the columns it's going to create. Hopefully this is going to work. Might have to change an option or two to get things to work. And then click Next and Finish, and that would import the data into the Excel worksheet. Next, you should be able to make some scatter plots. Use the column with the percentage and the column with time until the end of the fire, and then separately use the columns with percentage and the number of trees left. Choose Chart in both of these cases from the Insert pull-down menu. Click on XY Scatter and click on the type of plots. If the data is not in increasing order, mine was actually in decreasing order, only select the top plot, because that it automatically figures out where to put all the points in the scatter plot. Click Next and add titles, etc. And then you should be able to name the charts and give values for each of them. If you haven't used Excel for plotting, I'm not going to go over this in detail, but we'll do a quick demo of it. So then, depending on how much data you captured, this only has a few data points. I captured a lot more data points than this in my little experiment, so my graphs will look a little bit different. And if you label them with similar labels, you can see that as we vary the percentage of trees, the time until the forest fire stops varies in this particular case. In the experiments shown here, from 60 to about 130. The experiments that I ran are over a shorter time period, so that the y-axis will not have the same values on it. And the number of trees left, in this particular example, there was a lot more trees in the run in the simulation. And you can see that most of the time the number of trees left was pretty high when there was low values of percentage of trees. Now my experiments were run quite differently, so my graph will look different, but the format will be very similar to this. Alright, so I've opened up Excel. I want to go to the Data tab here, and I want to get it from text. So then I need to go to where my file is, which happens to be on Google Drive, and here, and a lot of navigating here, sorry about that. Here's my data file. Import. It looks like it's going to place them in the right place, so I'm going to say next, and finish. And it says, where do you want to put it? I just want to say, okay, this is off screen, so I'll move it over so you can see. It comes up and says, import data. Where do you want me to put this data? Right where it's positioned. So now it gives me 3 skinny little columns that start showing the density of that particular experiment, the time at which the trees stopped burning, and the final number of trees. So for the 64, there was very few trees left, just a couple. I go down to 62, the same thing. So mostly my experiments aren't getting very interesting when I get clear to the bottom of my data down here, gets a little bit more interesting. Finally, at 52, we have at least one case here where the number of trees left was 30, so not too many trees left. But we should be able to create plots, and that's what we wanted to do here. We want to create a plot, which is an insert a plot, and we want to use the scatter plot. So I'm going to say create a scatter plot. I use that first type, and it automatically selected everything. This didn't do exactly what I wanted. So let me try again, selecting the right columns. So I'm going to just click and delete that plot. This time I'm going to select these two columns first and do the same thing. Select, insert, scatter plot of the first type. And now you can see that it automatically scaled the plot. It's actually useful. It shows that the time at which the simulation quits is pretty tightly varied. It doesn't seem to be very much dependent on the values that I chose, so maybe not particularly interesting. Let me scoot this graph in a little bit so you can see it better. So basically I've plotted the first two columns. I could now go in and I could set my plot scales to be more reasonable. It's actually useful maybe to go to 0, but you can see here there doesn't seem to be hardly any correlation between the densities that I picked, which were from 52 to 62, and the time that the fire stops burning. Maybe if we were to pull down into the 40s and 30s, we'd start to see some kind of correlation. But now let's go ahead and do one more, and I'm just going to make this a really tiny little plot, and I can just resize it here like this, and then I'm going to bring in one more. This time I'm going to select this column, and I'm going to hold down the Control key and select the next column. So we have these two columns selected, and now I should be able to insert scatter plot, same kind. And that's a little bit more interesting. Let me move this out in where you can see it. You can see now that there's a slight increase in the number of trees left for the lower values. All the higher values, there are very few trees. So there starts to see a little bit of trend, and we'd see a more interesting pattern. But the cool thing about this kind of graph, both of these actually, is at any given value you can see how many data points, and you can see how much uncertainty there is. You see there's a lot more variability all the way from 0 to 30 at 52, whereas they're tightly clustered less than 5 when the value is at 62 or 64, whatever my top value was. So I think we'll call that good for just demonstrating how you could bring stuff over into Excel. Certainly you can go in now and label and fix these graphs all up. But this lab's already getting really long, so I think I'll call it good for this demo, this part of the demo. All right, this part of the lab asks you to add something that changes the way that this a new substance that makes fire burn differently somehow. So I'm going to add something called retard, which is like spraying fire retardant. I know you can't really do that on a big forest, but just for fun, in this little bitty forest, what if we dumped some fire retardant and it hit different patches so that some fraction of the patches had retardant on them? I'm going to keep it really simple. And then we're going to run some experiments to see what happens when the amount of retardant, if 100% of them get fire retardant, then clearly the fire should burn a lot differently. Not to 0, but a lot differently. And I'm just going to have the retardant make the fire spread at half. Fire spreads by multiplying by 5 per tick. I'm going to have it be half of that amount when there's retardant there. Then we're going to run experiments to see a sweep of retardant values just to see how the end results change. Just the idea of setting up an experimental condition besides your base of values. Okay, so I've just reopened the model. I've pushed the code tab, and I'm at the top of my code tab. The first thing I want to do is add a attribute or a variable that's owned by the patches called retard. And then I'm going to go down to the setup trees process where we ask the patches to, if there's a random value is less than a percentage, then set the patch color to green. Right after that, I am going to add another if statement that says if, I'm just going to sort of copy that, random of 100 less than what I called retard fract, retard fract, then set retard to 0.5. I'm going to add an else clause. I forgot to make it if else. Else set retard to 1. 1 is not going to have any effect, and that's the kind of what we want to leave alone. So if we have no retard, it won't have any effect. It'll leave things alone because we're going to multiply by this fraction. And this should say if else. Let's see how we did here. Nothing named retard fract is available, so let's go Control C, go over to the interface, and we're going to add a slider called Control V, retard fract, 0 to 100, and its initial value is actually going to be 0, so that it should have no effect. So now if all's right in the world, we should be able to run setup and have the thing go, and actually clear the command center. We can see what happened. Right now we have the value at 52 where I left it. And just real quick, let me set that up and do a go. And you'll see there's 20 trees left here in this particular run. And we could run a bunch more values. I'm going to run right around this value of 52 for my experiments. But what I want to do is be varying that retard fract. So for right now, let's just do sort of a dramatic test. This lab's getting really long, so I want to be careful not to overextend the time. But let's do a quick increase of retard fract to be very high. What should happen? If we run it up to 100, then they should all have this retard. Oh, I forgot to make an important change. I went over and fixed one problem, but I never updated the code to do anything with the value retard. So what we need to do is we need to go down here to spread, and here where it says to grow, this is where we want to insert our logic. Set fire to fire times 5, and then we want to just add times retard, because if retard is 1, it'll have no effect, but if retard is 0.5, it'll have an effect. So check the code, looks like we're okay. Now if we go back to the interface, we now have retard on 1. The fire should burn, it should burn differently now. So if we run setup and go, this time the fire actually looks like it burnt more aggressively. Let's just do a setup and go. So, boy, it's really hard to tell what's happening. But the idea here, and I think just in the interest of time, I'm going to pause this, do a little bit of experiment, and then report back really quickly. All right, I've done just a little bit of experimenting, and you can see here that I changed my logic so that it would set retard not to 0.5 but to something called 1 minus retard amount. So if retard amount is 1, the retard would become 0, and down in the spread logic it would not spread at all because it's completely retarded. At 0.5 we would have the same value we had before. It was hard to see anything happening. But this validates that the logic is working. So retard fract is there. And then down here, the way I implemented that was it says fire times 5 times retard. So when it was 0.5, we couldn't see much. But now that retard can go from, basically be from 0 to 1, we can suppress the fire growing at all, really, or we can leave it the way it was. And then over on the interface tab, I added this retard, where the fraction is the number of patches that have gotten retard on them, and the retard amount is, for those patches that have the retardant on them, how much does it retard the spreading of fire. So just to show quickly, if we set it up with the retard amount 0, then we just get kind of the standard fire burning. It just burns across really fast. But if we set the retard amount to be 1, even with just about half the patches having it, the fire burns much less aggressively. And if the fraction is set really low, burns back across again. So now we have two parameters for controlling how that retardant works. We could put it on all of them, but have it be only a little bit effective, like 40% effective. And that one actually burns across pretty good. If we move it down or move it up to about here, and it doesn't seem to have had much effect either. So what a combination of these two parameters seems to have the effect. And just to verify that we're okay again, if we do a setup with the retardant at 100, it doesn't burn very far. So now the idea here is you could run additional experiments similar to what we did before, experimenting not with just how the percentage of trees varies the way the fire burns, but also how this retard amount and the fraction of patches that have the retard could do it. That was the whole idea of this. All right, given a little bit more time, hopefully you'd run some experiments in that previous lab, save them as another output file, take that file over into Excel, and be able to create graphs to show the effects of your new substance. I didn't demo all that because this lab's going to be awfully long as it is. And for this last section, this bonus part, this is the kind of like really a fun part actually. You can now put part A and part B where you use that automatic parameter sweep logic. You can put that logic in and combine that with the forest fire model. You have to remove the stop command and set a switch and some other things. And I demonstrate all that. Instead of going through a demo of this, I've simply provided a file that you can open up and take a look at. And you could also try figuring this out on your own. It is a doable thing. And then when you run the model that I created has just a single run logic up above, and then the buttons down below, be careful about that, are the ones that actually run the simulation set, create all the data, and then you could copy and paste that data and do some interesting plots in Excel, just like we demonstrated earlier. So I think I'll wrap the lab up there and encourage you to learn as much as you can. And if you have any questions, we can talk about it. Maybe not tonight, since maybe none of you will have really done this lab yet. But I'll mention kind of what the recording looks like tonight.